Is it possible to create this kind of animation using only CSS? No, I don't think so. And the reason for that is because this animation depends on some external event. In this case, it's the mouse event, which is the position of the mouse we are moving. And since CSS can only work with what we call declarative animations, meaning that you have to create and predefine the keyframes of the animations and the options before you can run them. And you can't modify the animation at the frame level like while it's running. So that means our only option is to use JavaScript. And before we get into how we can create this animation specifically using JavaScript, we need to understand and learn how we can create any animation we want using JavaScript, like animations in general. And if you think about animations in general, you can define them as changing a value from one value to another. So from the initial to a target over time. So it should change gradually. So instead of changing, for example, the position from 0 pixels all the way to 100 pixels at once, just from 0 to 100, you can change that gradually, like incrementing it maybe pixel by pixel until it reaches the target. So that means we need some way where we can define some code and call that code repeatedly at some frequency. And then we get to the topic of timers. So if you've ever heard of timers in JavaScript, we have, for example, set timeout or set interval, where you can define a code, like a callback where you can define your code, and then the interval, how many milliseconds should pass so you can call the next iteration or call that code. So without further ado, let's go to the code editor and learn about that. Starting with the HTML code, so nothing is fancy here, we just have this div with a class circle, and in the CSS, we have this circle class which has width and height of 100 pixels, and some background color and border radius, and we are using position absolute, so we can set it at top and left 0 and 0. So you can see all we have this circle, and now we want to animate it. Now let's go to the JavaScript code. So in this JavaScript code, all we have is we are getting that circle element using document query selector and using the class name. Okay, so let's start with set interval. And to use set interval, you can say set interval, and it takes two arguments. The first one is the callback, the code that you want to execute, and the second argument is the delay or the interval, at which frequency you want to call this code. And it's in milliseconds. So for example, if I say 1000, so that means every 1 second we will call this code. So for example, let's say just a console log called. And if I save, sorry, this is a typo, so it should be in capital. And if I save, you can see now it says called every 1 second. So when it comes to animations, we don't want to log something. We want to change a styling property for that circle. So what we can do, we can say circle.style, and then let's, for example, update the transform translate. This is the best way where we can change the position of any element. So let's say transform, and then say translate, and we will give it the x and y in pixels, and y here in pixels. And then we have to define this x and y. Let's say x equals 0 and y equals 0. So we have to start them with 0 pixels. Now, what we need to do is to change this value from 0 to the target. So let's say that the target is just set it into a variable. Let's say that the target x should be 100 pixels. So it should reach 100 pixels and stop. And the same thing for the y. So what we can do, if I say, for example, x++ and y++, so every time we call this code, we need to increase it by 1 pixel. So just add 1 pixel and then it will move to the right and to the bottom. But this will not appear like as a real animation because at this point we are just using 1 second. So every 1 second we will increase 1 pixel, which is not how animations work. In order to make it smoother, we need to use a much smaller value. But before that, let me just save and see. So you can see it will just keep moving 1 pixel, and it's not that much. So what value we should use here? If you are aiming, for example, to something like 60 FPS, 60 frames per second, then we can say in every second we have 60 frames. So we need to call that code 60 times per second. So if you say 1 divided by 60, you will get a 16 about like 16 milliseconds. So if you use here, for example, 16 and save, you can see now it moves much smoother. But this will just make it move forever because we don't have any condition where we want to stop that animation. And remember, we said that we want the target for X and Y to be 100. So one simple way you can do it is actually we can use the capabilities of setInterval. It gives us an ID, we can say a timer ID, and then we can just check if, for example, either one, the X or the Y, is bigger or equal than 100 pixels, then just stop the interval. We can say clear interval and give it that timer ID. And if I save, and you can see it will just stop once it hits 100 pixels. Another way you can do it is that we can just remove this timer ID and then say I will keep updating this timing property as long as either X or Y is less than 100. So what I can do, just flip this and say while it's less than 100, and I move this and remove that code. So that means it will keep updating X and Y, but it will only update that transform property as long as it's less than 100. So actually, let's just use the target X just to make use of these variables and save. So you can see it's the same, except that this interval timer will keep going forever and we will always execute that code. But the idea is that we stop updating that styling property as long as, or once it hits the target X. But of course, this is not the best way we create animations. We usually, when we create animations, we specify things like the duration. For example, the duration that this animation will run, let's say it's 2 seconds. So we should update it or move the circle from 0 to the target over the 2 seconds or 3 seconds, whatever duration you define. So let's just do that quickly and say duration, and let's give it 2000 for 2000 milliseconds, which is 2 seconds. I'm not going to go through the mathematics here to explain it in details. I might do this in another video, but for now, I'm just going to show you how you can quickly do this. So the idea is that once we switch it to duration, that means we need to switch the animation to what we call time-based animations. So we progress the animation and keep it moving while the time is passing. So that means we need to keep track of the time. And the time is like from some starting point, we can keep just incrementing and see how much time has passed since the start, and then we can calculate the progress. So let's do that quickly here. So I'm gonna say the start time here, and we can get the current time step using performance.now, just a quick way to do this. And what we can do then, we can get the current time, performance.now, and if we subtract them, we can get the elapsed time in milliseconds. So let's say elapsed, and say the current time minus start time, and that will give us the elapsed. And again, we need to progress it based on the progress or the division between the current time or how much elapsed divided by the duration to see how much we have progressed for that duration. And we can do this simply by saying progress and say elapsed time divided by duration. And that will give us value from 0 to 1. That's how we can measure the progress. But since it can also exceed the 1, so it can get 1, 1.1, then we should cap it at 1. What we can say is math.min and then 1. That means as long as it's less than 1, smaller than 1, then we can use this value, which would start with 0, 0.1, like incrementing it. But once it hits 1 and bigger than that, then we can cap it, and always the progress would be from 0 to 1. Now, we would use this as a way to calculate the current x, like the current x and y values. So what we can do, we can say x equals the progress times the target x. So for example, if the progress is 0 because the elapsed time is 0, then it will be just 0. But if it was, for example, 0.5, like the half, then it will get the half of the target x and it will reach 50. All the way, once it gets 1, then it will get the full target. So let's do the same thing for y and say progress times target y. And then we don't need to do this kind of check because the progress will always stop at 1. So what we can do, we can just remove this and save and see. And you can see it's working like before, but it's now much better because we are using what we call time-based animations. Now, before I get into the next topic, let me quickly extract this callback into a separate one. So we can say const tick, let's call it tick, because this is every tick. And what we can do is just get that code and paste it here. And then just make it, call that every 16 milliseconds, and save, and you can see it works. Now, do you think this is the best way to create animations in JavaScript? Actually, this is not the best and the most optimized way. You might not notice it here. It seems that the animation is very smooth and it works. But this is because this animation is very simple, and the calculations are not that expensive. But once you have more expensive calculations and more complicated animations, then you will see that sometimes your animation will stutter and not be as smooth as this. And I'm going to explain why in a little bit. But to show you how you can make it much better and give the best performance, let me show you that. Now, instead of using setInterval, I'm going to use what we call requestAnimationFrame. I'm going to explain why this is much better, but let me show you how easy it is to switch to it. So what we can do is just replace setInterval to requestAnimationFrame, and it still takes that callback tick, but it doesn't take the duration here or the interval. So let's remove it. And if we save, you will see that nothing happens because what requestAnimationFrame does, it gives you just a slot in the next frame so you can run any code you want for the next frame. And that only does it for the next frame. So it doesn't call that code repeatedly. So in order for that to work, we just need to copy this and paste it here so it will call it recursively. And if we save, you will see it will have the same effect, except this is much better and it's better for the performance. And to explain why, let's see this diagram. So you can see on this screen, we see this timing diagram for vsync. So what this vsync is? Vsync is a signal that your GPU sends to the operating system that it tells it that I'm going to display something on the screen, like the pixels, new pixels. And it does that on some frequency. For example, if your refresh rate for your monitor is 60 Hz, then it will call that 60 times per second. So 60 times per second, we will display something new on the screen. And like before, if you divide 1 by 60, you get around 16 milliseconds. So every 16 milliseconds, we will send a new vsync signal. And that tells you that I'm going to display something on the screen. And that image we display on the screen, we usually call it frame. So that means on 0 millisecond, we will display the first frame. So the first thing you see on the screen. Then after 16 milliseconds, we display the second frame. And after 32 milliseconds, we display the third frame. So a frame is the images or the pixels you see on the screen. And you can see there's a period between every vsync. So from displaying the first frame to the second one, we have this 16 milliseconds. And what this period is for is that it gives you a room where you can generate the frame or prepare the frame or whatever you want to display on the screen. So between the 0 milliseconds and the 16 millisecond here, you have this time where you can run any code you want and display it on the next vsync. So something is displayed on the screen. So let's say I ran some code here and prepared for frame 2 and I display it here. Then here, I prepared for frame 3 and display it here. But what would happen if you fail to deliver it on time? So what would happen if your code ran much more or took more time than what we have here? What would happen? It will display the previous frame because you can see this vsync signal is hardware driven. So it will always display something or send that signal, regardless whether you have something to show or not. And when it doesn't have anything new to display, then it will just fall back to the previous one. So for example, if I can't get the fourth frame here, something new to display, then it will just get to frame 3 again. And if that happens a bunch of time, like in a row, then that will appear as if the screen is frozen, or sometimes the animation will appear as stuttering. So what we need here is to always make sure we have something new to display on the next frame when I'm talking specifically about animations. But what does that have to do with setInterval and requestAnimationFrame? So let me show you that. So here's another timing diagram for the setInterval. And you can see these orange circles, they determine when our code inside that setInterval starts to execute. And you can see it doesn't start from the beginning, like at the same time where we start the signal. We start here. And that means we only have this time to run the code, which is less than the whole period. And if we took at the next period, it even starts later than that. So we even have less time here. And you can see it keeps shifting, maybe at some point where we have the time. So we only have that time to run the code. And remember, if you fail to deliver that new frame at that time, then you will get to the previous frame and then you will have some stuttering in your animations. But if you use requestAnimationFrame, you will get a better performance because you can see that the start of the requestAnimationFrame code starts almost at the beginning of the period. So we have the whole period here to run our code. And if our code is much more complicated than the one we have more room to run the code and finish it by the next frame. Whereas in setInterval, if the code is much expensive, we might fail to deliver the next frame and then you will get that stuttering. So setInterval wasn't designed for animation in the first place. It's just a timer. Whereas requestAnimationFrame was designed specifically to be aligned and synced with the vsync signal. So you get the best performance because you have more time to deliver the next frame. And that's it. That's all you need to learn about requestAnimationFrame. It's just another timer in JavaScript where it's aligned and synced with vsync so you get a better performance. So before I end this video, let's see how we can implement the follow the mouse animation I showed you at the beginning of this video. You will see that this animation is much simpler than you think. So first, since we don't have this kind of time-based animation because it depends on the mouse event, we can remove this duration. We will keep the target for now, and we don't have this concept of start time or elapsed or progress. We can remove all of this and remove the progress here. And let's now do the next thing, which is we want to get the target X and Y based on the mouse position. And we don't want it to hard-code it as 100. Let's keep it and make it start with 0. And then we can listen to mouse move event on window. So let's say add event listener and mouse move. And let's get the event object. And then we can say target X equals event.clientX, which gives us the current mouse position. And let's do the same thing for target Y. And now what do you think would happen if I save? If I save and I do this, you can see it follows the mouse but without animations. Because we need to increment or do that kind of change of value from the current X to the target over time. So we need to do some kind of delay. And what we can do, we can use what we call exponential decay. So I'm not going to get into the details of this. This might be for another video, but the idea is that what we can do is we can say X equals the current X plus the distance we have. So what we can say is target X minus X, we get the distance we need to go, and then times some rate. So this rate can be from 0 to 1. 0 means it will not move. 1 means it will just have no animation. It will just be the same like before. And what we can do the same thing for Y and say target Y minus Y and use that. And the bigger this value is, the faster it will be. So if I do 0.1, it will be like before. If I do 0.2, it will be faster. So let's save and show you. And you can see now it moves like before. If I make it, for example, 0.2, or actually let's make it 0.4, so it's much faster. You can see how now it's much faster. One more thing before I finish this video. So you can see this requestAnimationFrame calls this callback. And if you remember previously when we created this time-based animation, we could use get the current time using this, current time, performance.now. But with requestAnimationFrame, you can get this from the parameters. So what you can do is just say timestamp or current time. And that will give you the current timestamp without needing to do performance.now. So this is a quick thing I wanted to show you for the sake of completeness. So yeah, that's it for this video. So now you know what requestAnimationFrame is for. I might dedicate more videos in the future showing you how you can create more sophisticated animations. And until next time, be creative with your code. See you in the next video. Thanks for watching.